All right. So we're going to do 3 more conversion problems. And in this one, I didn't ask you to do the pseudocode. If you think that the pseudocode will help you think it through, then please do so, but I didn't ask for it. Since a lot of people wanted to turn in Python for the pseudocode anyway, you may like that. So anyways, the first problem, tribbles. This is for the Star Trek fans. Say that 1 bar of gold-pressed latinum is worth 20,000 Federation credits, and a tribble is worth 10 credits. Now, if you don't know what latinum is and you don't know what a tribble is, all you need to know is that you can convert latinum to credits and credits to tribbles. So the program needs to work like this. Ask the user how many bars of latinum they have and calculate and display how many tribbles that could buy. Because, of course, you know that the Ferengi on Star Trek love tribbles. I'm kidding. So anyways, the program needs to run like this. How many bars of gold-pressed latinum do you have? 3. Great news. That'll buy you 5,000 whatever tribbles. Now, this number isn't right. I didn't do the conversion myself. I totally made it up. So don't run it and then get upset that your number doesn't match that. So that's my parenthetical. Note the conversion is not correct. And also, maybe you don't want to buy 0.9 tribbles, so because it's a creature. So you can round the answer up to a whole number with the math.round command. Or just by casting it to an int. Converting it to an int, excuse me. The second problem. So there's going to be 3 scripts to this, but we're going to do one of them in class. You like bathing in a bathtub full of milk. I know I do. The bathtub holds 40 gallons. The cost of milk is $3.85 a gallon. You always discard the milk after each bath because reusing your milk would be nasty. You ask the user how many baths they would take. Calculate and display how many gallons that would take and how much that would cost. How many milk baths do you want to take? 7. That will take 201 gallons. That will cost $621. Again, these numbers are not correct. Just made them up. That's my comment. Conversions are not correct, and you could round the answers to whole numbers. After a little bit, we will talk about how to format our data so that dollars would always be correct, because we always show pennies when we show dollars. So we'd want to, force the output to only show 2 decimal places. You could round the data to 2 decimal places, but then if it was equal to 0.10, we don't want to display $621.1. We want to display $621.10. We will find out how to do that. Not today. And the last one, sugar. I had this one called Sugar Addict. I should have left it like that. A pound of sugar has about 1,700 calories. It is generally accepted that 3,500 unburned calories equals about a pound of weight gained. Ask the user how many pounds of sugar they eat in a day. Walk around with your bag. Display how much weight gain that would cause in a week. That makes it a little bit more complicated because it's not a straight conversion from sugar to calories to weight gain. Then you have to figure out how to make it per week. So how many pounds of sugar do you eat in a day? 5. If you do not burn that off, you might gain 7 pounds in a week. 0.5, whatever. So again, the conversions are not correct. After we finish this one, or as we work through this one, I'll add a second page of notes, which may help with the programming. But number 1 and number 2 should not be that hard based on what we're going to do to number 3. Now, yesterday when I taught this, I went and I drew on a board how to do conversions on paper. I may go ahead and do that. I don't know if it just makes things more confusing or not. Yeah, it makes things more confusing. Forget it. Okay, so we want to do 3 here. A pound of sugar has that many calories. So we could write our equations, our conversion equations, even before we start, kind of like I did for the other assignment. If 1 pound is equal to 1,750 calories, that means that calories is equal to 1 pound times 1,750. Don't know if that makes sense, but if 1 pound is equal to that, then 2 pounds is equal to 7, twice that much. And if you're used to fractions, you could express that as 1 over, well, I did not mean, don't put a long line there. 1 over 1,750, and then you're trying to put, a 2 here, and you want to put an over there. How would you solve for that? Come on, math fans. Haven't been that long since algebra. Okay, so it's been 4 years, whatever. If that's x, and you have an equal sign between these two things, how would you solve for that? Cross multiply. So x is equal to 2 times that. So in general, calories is equal to 1 pound times 750. If you want to go into the reverse, pounds is equal to calories divided by 1750. Okay, that handles that first conversion. The second one, 3,500 calories to pounds of fat. So 1 pound fat is equal to 3,500 calories. That means that pounds of fat is equal to, I know I messed that one up. Calories is equal to pounds times 3,500. So that means that pounds of fat is equal to what?
30 calories divided by 3,500.
Exactly. Calories divided by 3,500. And do you have to figure out all of these before you solve a conversion problem? If it's a one-way problem like this is, not really. But I'm trying to get you set up, so if I ever gave you any further ones, you could do it. All right. We're about there, but 1 week is equal to 7 days. That pretty much just means that when we calculate how much weight gain per day, you're going to want to multiply it by 7 to get to how much weight gain per week. Hope that makes sense. You gain 1 pound a day, you're going to gain 7 pounds in a week. So these equations, I'm just going to put that as a comment and that as a comment, are pretty much what we're going to use. We're just going to have to string them together. We're going to ask the user for the pounds of sugar, and we need to convert that to pounds of body fat. So our pseudocode will look something like this. Input, pounds, sugar. Maybe I'll call it sugar pounds. Then we need to convert. We can't go directly from pounds of sugar to pounds of body fat, but we have an intermediate value. So we need to go calories is equal to, so calories is equal to what? What did we decide the connection between pounds of sugar and calories was? Which one of these two sugar equations would help me figure out this? I'm sorry, we're dealing with the sugar right now. We've asked for the sugar pounds, and so we need to convert to calories. Which one of those two is a good conversion?
Calories divided by 7.
Yeah, so no. We're trying to calculate calories. We don't have calories. So we're going to do that one. Right, so we're going to do sugar pounds times 1750. Now we need to do the second conversion. Set fat pounds equal to what? Which of these two equations fits the bill? The first one or the second one? I'm sorry, I didn't quite hear you.
First.
Okay. Fat pounds equal to fat pounds times 3,500. We don't have fat pounds. We can't multiply it by 3 by 3,500. We want to calculate fat pounds. We have calories. So which of these two equations is good? That one. Calories divided by 3,500. Okay, that would get us the amount per day, because this was pounds of sugar per day. So in order to calculate pounds per week, we just need to multiply it by 700. So set fat pounds per week is equal to fat pounds times 7. Bless you. If I wanted to make a totally correct pseudocode, I'd put a start, I'd tab everything over, and I'd put a stop. All right, we can convert that to Python pretty easily. Maybe I should do one more sample conversion after we do this. Because like I said, this one was more complicated because it has 3 steps, not just 2. The others only have 2 conversions. You only have to do 2 calculations in it. This one required that 3rd one. Okay, let's pop open Python. Pop open idle. File new. I'm just going to call this one sugar. So I'm going to do a save as, put it in my favorite folder, wherever that is, sugar.py. That is my pseudocode. I'm going to see if I can dock this on the other side of the program. Whoops, come on. There we go. Kind of a split screen thing. So we need to input the sugar, but we're writing pseudocode. Let's put our name up here. Bob Dylan's writing this program. It's February 8th. Sugar to weight gain program. Calculator. Alrighty. We don't need the start command. How do we input sugar pounds? Yeah, I could just throw an input statement up there, but what are we likely to want to do? Seems like there are 3 steps whenever we have input. What are they? What did we do in our other program? Yeah, you got to ask the question, do the input statement, and then convert it to a number. Is that making sense? I had about 20 non-answering people, so I'm really hoping that this makes sense and that y'all were just shy. Okay, so print. How much sugar, or how many pounds do you eat in a day? Now we need to input. What is a good syntax for that? Yeah, I could use a variable like x. I'm going to try to shy away from single letter variable names in this case, because we're dealing with, things like pounds of sugar. I may as well give good names. So sugar pounds, or sugar pounds, sugar LBS, whatever, is equal to input. Then we need to convert that. We have that, so we need to pass that in to an int or a float. I'm just going to pass it into a float. What if they say they eat 0.5 pounds of sugar? That would not work with an int. It would give us a runtime error. All right, we've done the first step. How do we do that second line? It's pretty easy, actually. And when I say second line, I mean that one. What do I feel like typing there?
Calories equals sugar pounds.
Right, it's just the equation without the word set. If I feel like putting a comment, conversion, I can do that. Doesn't matter whether I make calories uppercase or lowercase, I just have to do that everywhere I use the word. Calories is equal to sugar pounds times 1750. I'm just going to go straight down the line and implement these set commands as well. Fat pounds is equal to calories divided by 3,500. Now it's kind of weird, but that's like a 2-to-1 ratio. You could figure that out and take advantage of it to simplify your calculation, but I didn't want to bother doing that. You could do this entire calculation in one blow if you wanted to. We'll reword that. All right, now let's calculate the fat pounds per week. Fat pounds underscore PW for per week, or just the whole word week would work, is equal to fat pounds times 7. I'm going to put a comment out here. Per week.
Do we need to do that too?
You don't have to put the comments. If you think it makes it easier to read, go for it. Now we just need to print our answer. Now I asked for the answer to be in a slightly more complex format than what we did last time. Here's what we could have done, but don't do this. This would be okay. Fat pounds gained in a week, colon. That would work, and then our variable name. But we could display the message in a more friendly fashion, which is if you do not burn that off, you might gain that in a week. The trick to this is how do we get that number in the middle of the sentence? We'll see. We just add things to our print statement. So print, if you do not burn that off, comma, you might, and I'm going to have to drag this over to get the whole sentence on. You might gain, comma, and now we have a variable, fat pounds PW, comma, per week. Now it went off the edge of my screen, not yours. So what I'm going to do is I'm going to use the backslash, which means go to the next line. You don't have to put that backslash there, and you can put it all on one line because it all fits on one line on your screen. The backslash there just means that this line is continued here. And you could really use it anywhere. If I wanted to, I could put a backslash here, you know. I could put a backslash here. Why would I do that? I don't need to do that. That just makes it way harder to read. But if you had a line, a calculation that was like, 260 characters long, then you might want to break it up into multiple lines, and that's how you do it. Okay. Everybody seen this message and I could undo that, or maybe I'll just leave it. Let's test it out. How many pounds of sugar do I eat in a day? I eat 1 pound of sugar a day. If you do not burn that off, you might gain 3.5 pounds a week. That gives us a hint that we could have simplified this calculation. Just do a straight conversion from pounds of sugar to weight gain a week. I want to cover how we would do that. We would kind of work in reverse. Don't do this unless you just really want to, because I'm going to do a whole bunch of editing. Just kind of watch the process. Okay, fat pounds per week is equal to fat pounds times 7. But what are fat pounds equal to? Go up to the next line. What are fat pounds equal to? Calories. So I could take that, substitute it for that. Now what are calories equal to? According to the next line. Yeah, so I could take that and replace it with that. Now I did the calculation all in one line. If you feel mathematically inclined and want to do that, that's totally okay with me. or not. Okay, so that's part of our in-class assignment. I want to do one more conversion. I'm not feeling like we're totally clear on it. And for some of y'all, you're going, give me a break. I'm tired of this. Okay, so we're going to say one cake takes 12 eggs. That's a lot of eggs. And then 12 eggs equals 1 dozen. And we're going to say that 1 dozen eggs costs $2. That's another 3-step conversion. We're going to ask how many dollars they have, and then we're going to output how many cakes that makes. All right, that's the problem description. You don't have to type that in unless it just helps you remember this process. Let's come up with our 3 equations. Let's turn this into an equation first. If one cake takes 12 eggs, if we do this, eggs is equal to cakes, it's either going to be times or divided by something. Eggs is equal to cake times 12 or divided by 12? Times 12, because if one cake takes 12 eggs, 2 cakes takes 24 eggs. We all good? Half good? Okay, cool. So eggs times 12. That means that cake equals eggs what? Did I hear it yet? Yeah, divided by 12. There we go. So we've done this conversion. We've handled that conversion. Now we're going to do this one. This one's trivial, just because we know it in our head. If 12 eggs equals 1 dozen, eggs is equal to dozen times 12 or divided by 12? You buy 4 dozen eggs. How many eggs do you got? So it's going to be multiplied. I really need to bring cookies and hand them out to the people who talk, because some people just look at me because you don't want to answer, not because you don't know the answer. Alrighty, that means that dozen is equal to eggs divided by 12. Lastly, we're going to convert dozen to dollars. If 1 dozen eggs costs $2, a dozen is equal to dollars times 2 or divided by 2? Times 2. We've kind of been following a pattern here. If we worded it like this, if one cake takes 12 eggs, oh, I think I may have botched that one. No, I don't think I did. Something's bugging me about it. Anyways, a dozen eggs, that's actually wrong. So if it probably would have been easier to do this one first. Dollars is equal to dozen times 2 or divided by 2. Well, if 1 dozen costs $2, then 2 dozen costs 24. So it's going to be times 2. That means that the dozens equal the dollars divided by 2. And if when I was asking this one, if you said divided by and I didn't hear you, I apologize. You knew it and I didn't. Hope that makes sense. Based on that knowledge,
We could do pseudocode for it. What was it? Ask, start. Input the dollars they have, and then down here at the bottom, we're going to output the cakes. So we have a couple of steps. Once you have dollars, set dollars equal to, all right, which of these would be a good equation to go for? Hint, if it says set dollars equals to, you're going to want an equation that says dollars equal to. So let's just go with that one. Now that we have dozens, we can deal with dozens here. So, which of these would be a good equation? That's totally wrong. I'm going off in outer space. What's wrong with that?
You have 1 dozen versus a dozen eggs.
If I ask for dollars, but I don't know how many dozens we have, why would I ask for dollars and then start trying to calculate the number of dollars? That was my brain seizure. We're going to fix that. If I have dollars, once you input dollars, dollars ought to be the thing over here. So it ought to be set whatever equal to dollars whatever. So based on that, we want to do that. Set dozen equal to dollars times, no, divided by 2. All right, now we have dozen, and we want to convert that. So it's going to be something like set something equal to dozen, either times or multiplied. Which of these would be a good fit for that? The eggs. So set eggs equal to dozen times 12. And then now we've calculated eggs, so we need an equation that's going to look something like set blah 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 is equal to eggs and then times or divided by something. Which one of these fits that bill? Cakes is equal to eggs. Divided by 12. Put my stop in the wrong place. So this is pseudocode. Let's turn that into a real program. Slam that over there. I think I'm just going to tack this onto the bottom of our sugar program. It's thematically tied in. You know, we like sugar, we probably like cake. Okay, to input dollars, we need to do the 3-step shuffle again. What's that?
Ask the question, define the input, and set the float.
Exactly. So print, how many dollars do you have? Let's do an input. Dollars is equal to input. And then let's convert it to a float in case they want to enter fractional dollars. I didn't walk around and make sure that everybody had the sugar problem compiled, so I will do that as soon as we're finished with this one. All right, we're done with that step. As we saw last time, the way you do this math now is you just leave off the word set. Dozen is equal to dollars divided by 2. Eggs is equal to dozen times 12. Cakes is equal to eggs divided by 12. I didn't specify a form of output, so I'm going to make it easy on myself. Print. That would make, comma, now I'm going to use my variable, comma, cakes. That's ignoring the fact that you need other ingredients for cakes too, huh? Can't just make them out of eggs. We need the frosting. How many cans of frosting do we need? Anyways, okay. There we go. Let's run it. We're going to have to answer the questions for the first one as well. How many pounds of sugar? I eat 100 pounds of sugar a day. Okay, that's a lot of weight gain a week, 350 a week. Okay, how many dollars do I have? I have $10, and it blows up. It says cake is not defined. I made a mistake here. Brownie points to the first person who spots my mistake. Yeah, look how I spelled this here. And then I left off the S there. All right, now I'm going to eat only 0.1 pounds of sugar a day, so I might gain 1/3 of a pound a week. Then how many dollars do I have? 10. That'd make 5 cakes. Sounds right, I think. Again, let's roll this into one equation. All right, if I'm going to roll this into one equation, I'm going to start with the bottom one and work my way up. Cakes is equal to eggs divided by 12. But what are eggs? They're a dozen times 12. Wait. This sounds like I made a mistake. Okay. I used a dozen and then I used a dozen again. That was dumb. Okay. Stupid problem. Anyways, eggs divided by 12, but an eggs is equal to a dozen times 12. So I could replace eggs with a dozen times 12, and a dozen is what? It's dollars divided by 2. So there we go. There's a pretty blatant simplification that could be done there. Any of you mathematically inclined see a way that we could shorten that considerably just in one fell blow?
Dollars divided by 2.
Yeah, because what's 12 divided by 12?
1.
Times 1. What's anything times 1? Itself. So there we go. We could have simplified it considerably. Okay, and before you'll accuse me of beating a dead horse, we're going to continue to beat it. Let's, we know that 1 ton equals, is it 2,000 pounds? I think so. And we know that 1 pound is equal to about 2.2 kilograms, although I got on people's case if they did that, because in my assignment I said 0.4 whatever pounds is equal to 1 kilo, whatever. I got that backwards even. .2 pounds is equal to 1 kilogram. And 1 kilogram costs, kilograms of what? I don't know. Costs $3.
we want to do this conversion. We want to start with money and work back. Sure, why not? Input dollars. Okay, I'm going to show you how they teach you to have to do this like in a chemistry class or something where you're doing conversions. What you do is you start with your given, which in this case is dollars. And then you multiply it by a conversion ratio. Dollars times, okay, the only thing we have here is that conversion ratio. $3 over 1 kilogram. So we could either write it as 1 over $3, or 1 kilogram over 3, or we could write it as $3 over 1 kilogram. In this case, since dollars is on the bottom, on the top, we'll want to cancel our units. So I'm going to put $3 is equal to 1 kilogram. Now we're going to go to the next step. 2.2 pounds, 1 kilogram. We could express that as this ratio, 2.2 over 1 kilogram, or we could express it as 1 kilogram over 2.2 pounds. I want to cancel out kilograms, so I'm going to put kilograms on the bottom. Which of these is more appropriate? Yay or nay?
Top one.
Yeah. So 2.2 pounds equal to 1 kilogram. All right. One more conversion to go. 1 ton, 200 pounds. Based on what we've already talked about, what unit are we going to put on the bottom? The tons or the pounds?
Pounds.
We're going to put pounds so that we can cancel. And we said that 2,000 pounds is equal to 1 ton. Now if we cross off all of our units, we get that dollars is equal to 1 divided by 3 times 2.2 divided by 1 times 1 divided by 2,000. And we could express that as one equation. Dollars is equal to 1 divided by 3 times 2.2. I'm going to skip the divided by 1. Times, I'm going to skip the times 1, divided by 2,000. I could clean that up further if I wanted, but that would figure it out. Not dollars is equal to, dollars was our input. Dollars times that, because that was our given. We asked for that. That would give us the number of tons. Might be useless information to you. If you take a class where it needs it, you'll flash back on it. Sometimes some tutors or profs do it like this. We have a line across, and you just put little vertical lines like that. Alrighty. I don't think we're going to do any more pseudocode or any more conversion. Go ahead and upload that script or 2 scripts if you wrote it as 2 scripts into the conversion box.
Code or the pseudocode?
I'd like to see the code, but if you have the pseudocode, do the pseudocode too. Why waste valuable keystrokes? Go ahead and upload them. That way it's always available to you. You can download it again later. And I forgot to wander around. Let me pause it. Alrighty. Last thing we're going to broach. Talk about for a few minutes, then we'll talk about it more next Monday. The idea of functions. We did some functions when we were playing with turtles. We drew flowers or whatever. The syntax for a function
you use a DEF. I'm going to define my function. My function has a name, then it's some parentheses. If that function needs any data, you define your data inside the parentheses. Then it's a colon, and then everything that's indented after that function, everything that function needs to do needs to be indented. So in Python, a function, well, in every language, it's a named sequence of statements that belong together to do a job. They help us organize our program into chunks. We have written a couple of programs here. I'm going to just kind of tuck this to the side as my cheat sheet, but I'm going to rewrite it. Now, I said I wasn't going to ask for any more submissions, but if you want to type this and get it working, that's okay. This program could be turned in to a series of functions. Why do I say that? Because we get some input, we get some conversions, and we do some output. Conceptually, there are 3 blocks. Now, honestly, this input could be done in a single line of code, so turning it into a function would not be that valuable. But why not? Let's go ahead and do it. So I'm going to define a function called getSugar. Define DEF get underscore sugar. Does it take any parameters? No, at this point we don't have any data. We're at the beginning of the program. So I'm going to use just 2 parentheses with nothing between them. Then a colon. That's how I define my function. It has a name. It accepts no data. There we go. Now I'm going to do these 3 things. Print how many pounds sugar. I could shorten these to just like X is equal to and stuff like that, but sugar pounds is equal to input. Then I need to convert that. Sugar pounds is equal, you know what? I'm going to start shortening these a little bit. Sugar pounds is equal to float input. Do that in 1 line rather than 2. Then I need to return that value. Why do I need to return it? Because that data that we just asked for is going to be used somewhere else. So return sugar pounds. We haven't seen the return statement yet. That's because when we were drawing flowers, we didn't need to return a value. But this time we've got something, we did some conversion, so we have useful data, so the function needs to return it. Now the program needs to do the conversions. So define, convert, that's enough. We're going to pass in the pounds of sugar, and we're going to return the pounds of fat. So I'm just going to call this one sugar. Shorten it a little bit. 1 slight. Why take shortcut? Sugar pounds. Okay. Then I just need to do these 3 statements. Calories is equal to sugar pounds times 1750. I'm just typing them in again. I could have cut and pasted. Fat pounds is equal to calories divided by 3,500. Fat pounds per week is equal to fat pounds times 7. Thanks. Calories. And then I need to return that value. Do I need to put a blank line? No. Fat pounds per week. Then we have an output. DEF output. And what does it take? It takes fat pounds per week. Fat pounds per week, colon. And that's just a print statement. Print, I'm going to shorten it. Pounds may be gained, colon, or comma, fat pounds per week. I've defined 3 functions. I can use them now. This one doesn't need to return anything. All it does is print something. It doesn't do any calculations. So let's do this. Sugar pounds is equal to get sugar. We call our first function. Then fat pounds per week is equal to convert sugar pounds. And then output fat pounds per week. That's what our program looks like. That's the logic of our program right there. But the details are in these functions. Why do you do that? Well, if you're working in a big team, these could be separated into separate files. You know, and functions could be hundreds of lines long or whatever. And you say, okay, the customer wants this program to ask a question in French. So you tell your junior programmer, okay, I need you to go fix the get sugar function. Reword it in French. They go and open the file with that function, they edit it, they check it back into your source control system, they're done. They didn't have to touch anything else. It lets you be very specific, it lets you break the program up logically. Logically, this looks a lot like our pseudocode. This looks like an input, this looks like a convert, this looks like an output. I didn't run it to test it. That would be a brilliant idea. This will be the last topic. I'm going to call it sugar 2. How many pounds of sugar? 10. Pounds maybe gain 35. Okay, so it worked. Does this make it easier for you to read? I don't know if it does yet. It makes it easier for me to read. Why? It's divided into logical units. This unit all involves the input functions. Maybe it needs to ask 20 questions rather than 1. That'd probably be a bad idea. Then this one does all the conversions, and that's how we output it. So when we actually get to the logic of our code, I won't say the logic of our code, but these are the 3 things that actually get executed. Anything with a DEF in front of it, it gets added to the library of Python while it's running, but it doesn't actually do anything. If I deleted those 3 lines or commented them out, I'm going to comment them out. You don't need to do this. I'm commenting them out with 3 quotes. If I run it, it doesn't do anything. Why? These are just defining the functions. You write a policies manual to give to somebody. Policies and procedures. Just because you wrote it doesn't mean it does anything. Not till you give those policies to somebody and make them do something. So it's the first unindented code that actually gets run. You do all these definitions, but it's looking for unindented code. Aha! Here's where I actually start running. And so it does this line. Sugar pounds is equal to get sugar. This is what's known as a function call. Another fancy word for it is invoking the function. It invokes get sugar. So it runs up here, and it does the get sugar process, which executes those 2 lines, gets some input, gets some conversion, and it returns that value. That value comes back here, and with the equal sign is now in this variable. Then it skips to the next line. It invokes this function, convert. It calls this function. And it passes this data into it. So it runs up to here. Whatever data we have here gets put here. It runs those 3 lines, and then it returns that value. I'm throwing the ball back. Returns that. Which gets copied across the equal sign into that variable. Then we call one more function, the output function. We invoke that function with that data.
So it jumps up to the output statement. This variable gets the data that was passed in. It performs that line of code. There's no return statement. We could put it there. Sometimes I like to add return statements just to make it absolutely clear where the code stops. But honestly, the next unindented line is where the code stops. So that was unnecessary. Anyways, it returns. There's nothing left to do and it's done. Hope that makes sense, but we're going to talk more about functions. So if it didn't totally sink in the first time, that's okay. We did see that with the flowers in the goto as well. These are called parameters. Variable names don't really matter. I could call this one x. I could pass x into the function and store the result in a variable called y. I could pass y into that function. That program will work just as well as it did before. Way harder to read. You give somebody this, they're not going to know what it's doing. It's easier to type, harder to read. That's why I kept the variable names. This variable name does not have to match that variable name because this gets a copy of the data. Whatever is stored in that variable fills in that variable. Whatever is returned here gets copied into that variable. So this name doesn't have to match this one. This name doesn't have to match that one, even though they did in that example before I made that change. All right, let's call this turkey done. Are there any questions over what we did today?
Do we need to save this one?
If you want, you can upload it. It's up to you. Looks like useful code to me. Only takes, say, 30 seconds to upload it. All righty. Let's see here.